Hi, I'm Mara Freilich. I'm a PhD student in the MIT Hui Joint Program. So I study biophysical interactions and some mesoscale dynamics. But the project that I'm talking about here is kind of a simple bulk mixed layer model, trying to come up with a minimal model for wintertime biomass accumulation in the North Atlantic. And so recent autonomous observations in the North Atlantic have shown that you have this wintertime increase in biomass, and Zach mentioned it earlier in the Southern Ocean. And there have been suggestions that this is because of the deepening of the mixed layer and that dilutes the phytoplankton community, reducing the ability of the grazers to consume the phytoplankton. And what we found when trying to implement this into a model was that the dilution alone is not sufficient to cause this increase in biomass or this reduction in loss rates for the phytoplankton. Instead, you need to also have a kind of response by the zooplankton to the decreasing phytoplankton concentrations. And so we're suggesting that then you need to have a nonlinear grazing response, particularly at low phytoplankton concentration. And so what I'm showing is the two model results, with the red curve being a kind of constant zooplankton response function versus a nonlinear response function in the blue curve that allows for this decreased loss rates or biomass accumulation to winter time. And this suggests a modification to the kind of classic view of the critical depth hypothesis, where you say that the critical depth where you will cease to accumulate phytoplankton biomass is when there's a balance between respiration and grazing and the photosynthetic capability of the phytoplankton, and that has to do with integrating respiration and grazing and integrating photosynthesis with depth in the mixed layer. Suggesting instead that if you separate the respiration and grazing, if the grazing is not a constant function, then with looking particularly at the low phytoplankton concentration, you end up with a very nonlinear response in grazing. And so I'm not suggesting that grazing has a depth dependence, but instead if you integrate the curves the way that we typically do when we talk about the critical depth hypothesis, we find that the grazing response actually decreases a lot faster than the photosynthesis, and that's what enabled us to make this relatively minimal model of a bulk mixed layer model and reproduce this wintertime biomass accumulation without any complicated physics or more complicated zooplankton dynamics.